Hey everyone, my name is Will Valida. I'm a software engineer and Microsoft Data Platform MVP, and in this video, we're going to deploy our existing Azure Cosmos DB account that we've been building using Terraform in our previous lessons and learn how to deploy it using Azure DevOps, more specifically, using Azure Pipelines to deploy our Terraform code. But first, let's remind ourselves of our Terraform workflow. First, we initialize our working directory that contains our Terraform configuration files using Terraform Init. We can then run Terraform validate to ensure that our configuration is syntactically correct and consistent. We then create our execution plan using the Terraform Plan command. This reads the current state of our remote objects and generates a change plan of resources that are created, updated, or deleted. Finally, we execute Terraform apply, which will execute the actions that have been proposed in our Terraform plan. While this workflow works great for us when we're developing and deploying locally, when we start working on our infrastructure in a team environment, we need a way to be able to store our state remotely to ensure that our local changes don't interfere with any changes made by other developers in our team. In order to work remotely, we need to store the state of our infrastructure. Terraform uses this state to map our resources to our configuration. This is stored in a file named terraform.tfstate, which can be stored either locally or remotely. Terraform uses this file to create plans and make changes to our infrastructure. Every time we deploy our Terraform configuration, Terraform will refresh this file to update the state with the current state of our infrastructure. This state file will store bindings between what we've deployed to what we've configured in our Terraform code. And when we add or remove resources from our configuration, the Terraform state will be checked, and any resources that are updated, created, or deleted will be reflected in our Terraform plan. Now, to help manage our Terraform deployments, we can use Azure DevOps, which provides release management capabilities. With Azure DevOps, we can build release pipelines that can deploy our Terraform configuration to Azure. We can host our Terraform code on either Azure repos or GitHub and use Azure Pipelines to create our Terraform workflow as a release pipeline to manage and deploy our infrastructure to Azure. And that's what we're going to do in this upcoming demo. We're going to build our release pipeline to deploy our Azure Cosmos DB account to Azure using Azure DevOps. First up, we'll create our service principal, and I'll explain why we need to do that. We'll then set up our storage account to host our Terraform state file. And then once we have that set up, we'll create our release pipeline that we will use to deploy our Azure Cosmos DB account to Azure. Okay, so the first thing we're going to do is we're going to configure our remote state storage account. Now, before we can use Azure Storage as a backend for our Terraform, we have to create a storage account. So to do that, we can run the following commands using Azure CLI. So first things first, I'm going to create a resource group, and I can do that by going az group create, give it a name. I'm just going to go Valida Cosmos DB TF demo, and I need to provision it or create the resource group in a location, and for this I'm going to use Australia East. Cool, so that's all created. Now that I have my resource group, I can create my storage account. So to do this, I'm going to go az storage account create. I'm going to provision it in the resource group I've just created. Now I can use variables for this, but I'll just put in the name that I specified earlier. Valida Cosmos DB TF demo. Excuse me. And I can give it a name. So I'm just going to go Valida Cosmos DB TF. Just give it TF state. For the SKU, I'm just going to use standard LRS, locally redundant storage, and then I'm going to put encryption services at the blob level. Press enter. Oh, missed a dash, another dash for SKU. Just rectify that. And it's starting to provision my storage account. And thanks to the power of video editing, we can see that happened really, really quickly. And the provisioning state has been successful. So now I can create my container. So to create my blob container, I just go to AZ Storage Container Create. I'm going to give it a name. I'm just going to name it TF State. And I can specify the account name. That's the account name of the storage container that I want to provision. I want to provision my container into. Paste it into there. Press enter. And it's been created. So now that everything's created, I can actually go into my Azure portal, look for my storage account, and if we scroll down, we can see that my storage account has been created, along with the container that I created as well. So now we have everything that we need to use Azure Storage as a backend for our Terraform state. So with everything set up, we now need to make changes to our Terraform code to configure our backend. So what I'm going to do is just jump back into Visual Studio Code, and I'm going to configure my backend state by typing in the following. So I'm going to, in my Terraform block, just going to we'll write another block for backend. I'm going to give this a backend type of Azure. I'm going to need a resource group name, a storage account name, a container name, and a key. Now the storage account name will be the name of the storage account that we've just configured. So if I just go back into Azure, copy and paste that into there. We'll also need the resource group, or the name of the resource group that account has been provisioned in. So I can just copy and paste it here. Also need the container name, which is TF state. And then I also need to give it the key, which is the name of the state store file that's going to be created that will hold the state of my Terraform deployment. For that, I'm just going to use terraform.tf state. So now that my Terraform backend has been configured, I'm just going to commit that to GitHub. Now that my code's been pushed up to GitHub, I can use it as an artifact in my release pipeline. Cool, so before we create our release pipeline, what we'll need to do is we'll need to create a service connection. Now, if I just go into Azure DevOps here, we can create a connection from Azure Pipelines to external and remote services for executing tasks within our release pipelines. So once we establish a connection, we can actually view, edit, add security to that service connection. And we've used service connection for a variety of different reasons, but in this case, what we're going to be doing is creating a service connection to our Microsoft Azure account, so we can actually use out that service connection to deploy our resources to Azure. So let me zoom in a little bit here. And here I'm just going to go under Service Connections. Now here I've created some service connections already, but to create a new one, we just click New Service Connection. And for this, I'm going to use Azure Resource Manager. As you can see, we can create service connections for a variety of different purposes. But for this one, we're going to be using Azure Resource Manager. So I'll click on that, click Next, and I'm going to create an automatic service principal for this. And we can define it at a particular scope, so we can do it at subscription level, management group, or machine learning workspace. But we'll give it a name, so I'll just give it Cosmos Terraform Demo while my subscriptions are waiting to be loaded up. Cool, and I'll choose my enterprise subscription. I'll just leave it at the subscription level and click save. And so there's my service connection set up and ready to go. So now that I've set up my service connection, we can now start to create our release pipeline. So I'm going to go into releases and I'm going to just click new release pipeline. I'm going to start with an empty job. So we're going to build this up from scratch. I'm going to give this a name of Cosmos Terraform Demo. And first things first, I'm going to add an artifact. Now I'm hosting my code on GitHub, but as you can see, we can add particular builds. We can add repos from Azure repos, and we can also add stuff from GitHub. We can also add artifacts from Team Foundation version control, but for this, I'm going to use my GitHub. Now I'm going to be using a service connection to my GitHub account that I've created earlier. And I'm just going to link my Cosmos DB Terraform repository that I've got on GitHub. Let me just put my name in front of that, otherwise I'll get everything. There we go. And I'm just going to specify the main branch as the default branch. And I'm going to just pick the latest version or the latest commit that I've committed to this branch here. We can actually edit this to point at different branches, at different commits if we want to test something. But for now, I'm just going to use the main branch. And there it is, added as an artifact. So now that we've set up our artifact, we can start to create our deployment stage. So what I'm going to do, I'm just going to give this a name like deployment stage. Now, depending on how many environments you're running, you might have a deployment stage for your dev environments, you might have a deployment stage for UAT or production, but I'm only going to deploy it to one environment, so I'm only going to have one stage. But if I just open up my stage, essentially what we can do, we can actually specify jobs in our pipeline. Every pipeline has at least one job, and a job is a series of steps that run sequentially as a unit. So to do this, we can actually specify jobs that make up our Terraform workflow. So let's start with this. So to actually use Terraform on the build agent, I'm using one of Microsoft's hosted agents. I need to actually install Terraform onto the agent. So just search for a task for Terraform, use Terraform installer, and I'm just going to use the latest version of Terraform. Now, depending on how your Terraform code is structured, you might want to use a specific version of Terraform, but for this, I'm just going to use the latest version. And then for this stage, we're going to create the workflow that builds up towards our plan stage. So for that, I'm going to need a Terraform CLI task, like this one here. Just click on Add, and I'm going to use the Init task. So with this, we're going to initialize our working directory that contains our Terraform configuration files using Terraform Init. So here I've got my Terraform Init command selected. And now I need to choose my configuration directory. So if I open up this ellipses, and look under my linked artifacts, essentially I need to point it at the directory to where my Terraform files exist. So this is the file that I need, or folder I need, sorry. So just click OK. Press cancel. And now I need to initialize my backend. And for this, we're going to be using Azure RM. And then we need to provide some options to actually configure our Azure backend. So much like our file, I'll just open it up. Now I need to use the service connection that I created earlier. I might let that load up for a little bit. But as you can see here, I need to provide it the resource group name, the account name, storage account name, sorry, the name of my container, and also the key, which is my Terraform state file. And that's essentially saying, okay, here's my Terraform state file, use this as our backend. And I'll use the service connection that we created earlier. So now that's set up, we want to validate our Terraform configuration to make sure that it is syntactically correct. So I'll need another Terraform CLI task for that, just to run the validate. And the configuration directory that I'm going to point it at is again this folder here where all my Terraform code is. And then finally, I need to have another CLI task for my plan. So I can add it like so. Here, I'm just going to use the plan command. Going to point my directory to the folder to where my Terraform files are. Going to use that service connection that I defined earlier. And that's everything I need for my Terraform plan stage. Now remember, when we create our execution plan, this will read the current state of our remote objects that are sitting in Azure and compare it to a configuration that we've specified in our Terraform code, and it will generate a plan of resources that are going to be created, updated, or deleted. Now in previous lessons when we've run this command, what we've done is we've actually verified the plan before we've executed apply to ensure that what we want to create and what we want to modify is the resources, or are the resources, sorry, that are actually created and are modified. So we need a step to actually manually verify that our Terraform code is going to do what we want it to do. So to do this, we can create something called an Agentless Job. And here, I'm going to use a manual intervention task. And essentially what this intervention task is going to do, it's going to give us some instructions to verify the Terraform plan to view what's going to be deployed. And here we can actually notify users. So I'm just going to send an email to my personal email. And this will notify me to say, hey, the plan looks all good. Please verify it to make sure that what you actually want to deploy is going to be deployed. Now with Terraform Plan, we can actually write our execution plan out to a file if we want to, but for this I'm just going to use the build agent logs to verify my plan, much like that we've been using the terminal to verify our plan before executing apply. So let's create our apply stage. Now to do that, I need to actually create or add another agent job. Remember, we're using Microsoft's hosted agents. So again, we'll need to create another agent job. And for this one, we need to add another task to install Terraform. So I'll use the Terraform installer again. Again, I'm going to just use the latest version. Then I need to initialize my Terraform environment before running apply. So let me just configure this again. So for this, I need to use the init command. Need to point it to my Terraform files. Need to set it up for an Azure backend. Set up the resource group name, the storage account name, the container name, and then provide my Terraform state file as the key. And then finally, I'm going to use the Terraform apply command here. Going to use the folder holding all my Terraform files as my configuration directory. And I'm going to use the Azure service connection that I selected earlier. And that should be everything we need to initialize our Terraform environment, validate our Terraform code, and then create our execution plan. We have a manual intervention stage here, so we have a chance to verify our plan. And then once we approve that, we can kick off this job, which will essentially apply our Terraform configuration to our Azure account. So I'm just going to save that. And now that that's saved, we can go ahead and create a release. So to do that, just click Create Release and click Create. So our release has been created. We can just view the logs here. It's being queued at the moment. But once an agent is ready for the job, our job will kick off. And this is going to be our plan stage. Now, instead of making you watch this happen in real time, I'll just edit this a little bit. Cool. And with the power of video editing, we can see that our first job, our plan job, has succeeded. So if I just open up the Terraform Plan task here, as it loads up, we can see that our Terraform Plan has generated an execution plan of all the resources that are going to be created. Now, essentially, I've deleted the old account, and so we're starting from scratch. Remember, we're creating our resource log. We're creating all the diagnostic logs that we're setting to log analytics. We're creating our database in our account here, and we're also creating our container within our database, as well as our main Cosmos DB account. So now that I've verified the plan and I know that these resources are going to be created, I can just click resume. And this should kick off the job to initiate our apply stage. Cool, and with the power of video editing, our Terraform apply stage is done. You can see it took around about 4 minutes to apply my Terraform changes. But just looking at the logs, we can see that my Cosmos DB account was created, my database was created, diagnostic settings was created, as well as my container. So if I go into my Azure account now, give this a bit of a refresh, you can see that my Cosmos DB account has been recreated with my database provisioned along with the container. And if I just go into my diagnostic settings, I can see that my settings, to send my diagnostic settings to my log analytics workspace, has been provisioned. Now, if I just go back home and go into my storage account where I've configured my Terraform state to be stored in, and just go into this container, I can see that my Terraform state file is sitting as a blob within my container. So subsequent deployments of my Terraform configuration for my Cosmos DB account will check this Terraform state file and make any changes or updates to those resources as required, depending on what my configuration for my Cosmos DB account is. So this demo showed us how to actually set up set up a release pipeline in Azure DevOps to deploy our Cosmos DB account that we've created in Terraform via our release pipelines. That's the end of the demo. Let's wrap up. So as you can see, we can use Azure DevOps to manage our deployments of our Terraform configuration to Azure. In this video, we reminded ourselves of the Terraform workflow and the purpose of each command when deploying our Terraform configuration. After that, we introduced the concept of state in Terraform and how it can be used to detect changes between our configuration and our current infrastructure in Azure. Then in our demo, we set up an Azure Storage account to hold our state file remotely and used Azure DevOps to build a release pipeline to deploy our Cosmos DB account to Azure. So that's the end of the video. Thank you all for watching. I hope you found that useful. As always, if you have any questions, leave them in the comments. If you like this video, give it a like and make sure you subscribe for more content in the future. If you have any suggestions or topics that you'd like to see me cover, please let me know in the comments. Thank you all for watching, and I'll see you all next time.